So here are a few examples on using the unit circle to find exact trig function values. While the calculator can find your sine, your cosine, your tangent of a degree or a radian, you have these exact values that come from the unit circle or any of the angles that have reference angles for these, negative angles, positive angles, even taking the angles and wrapping it around a couple of revolutions. So you have to understand where the given angle lives on the unit circle, and then you can pull from the coordinate points. So if you recall, there were three trig functions to begin with. There was the sine of an angle, cosine of an angle, and the sine of the angle went with the y-coordinate from the unit circle, and the cosine of the angle went with the x-coordinate. So if we have really simple questions that ask you for the sine or the cosine and give exact values, cosine of 270 is just going to be the x-coordinate at the 270 degree angle on the unit circle. So if you go to that unit circle and look at your 270 degree, 270 degrees is down between the third and the fourth quadrant. The x value is 0, the y value is -1. We were asked to find cosine of 270. So the cosine of 270 is literally the x-coordinate at that degree. So for this one, we can say the cosine of 270 is 0. So I can go back to my answer and put cosine of 270 is 0. Okay. Sine at 5 pi over 4 is going to be the y-coordinate at the angle that has a radian measure of 5 pi over 4. So the pi's over 4 are the ones where at 45 degrees in all the quadrants. 5 pi over 4, again, if you need to go back to the unit circle, 5 pi over 4 lives here in the third quadrant. So both coordinate values are negative, square root of 2 over 2. So if we were doing, remember for sine or cosine of that one, we would get that sine value is negative square root of 2 over 2 for our exact answer. Cosine of 540 will be the x-coordinate wherever 540 degrees lives. Now 540 is more than your 360 degrees around the unit circle. So again, it's your responsibility to understand where does 540 degrees correspond as far as angles go on the unit circle. So if you take the fact that it went 360 degrees for one revolution, 540 would be 180 degrees more. So that would be 540. It would be one full revolution, or one full 360 degrees, and then plus 180 more, and that would put you back at pi and 180 degrees. So for the cosine of 540, the 540 degrees has a -1, 0 point, and we just need the x-coordinate for -1. Okay. 7 pi over 2, again, you have to understand where 7 pi over 2 lives. So if we look at our pi over 2's, here's 1 pi over 2, here's 2 pi over 2, here's 3 pi over 2, this would be 4 pi, so 5 pi over 2, 6 pi, every pi over 2 is 90 degrees. So 7 pi over 2 would live at the same place as 3 pi over 2, which has a point 0, -1. So at 7 pi over 2, my coordinate point is 0, -1, and I simply need the cosine, which is the x-coordinate. Okay, negative pi over 4, it's a negative degree, so we'll rotate clockwise to get our negative angle. And negative pi over 4 is going to live down in the fourth quadrant because we're just going down 45 degrees. And that point was negative or positive square root of 2 over 2 and negative square root of 2 over 2 for the y-coordinate. So if I do the sine of negative pi over 4, it's just negative square root of 2 over 2. Okay. Cosine of 240 degrees, again, it's just going to be the x-coordinate where 240 degrees lives on the unit circle. So again, referencing back that circle, find 240 degrees, or know where 240 degrees is, and then you'll end up pulling whichever coordinate you need. So that's -1/2, negative square root of 3 over 2, and we wanted the cosine value, so that would be -1/2. Again, it's just the x-coordinate at the 240 degree angle on the unit circle. So sine and cosine are pretty straightforward. Sine's the y value, Cosine is the x value, right? So then we introduce a tangent. So tangent is the ratio of the y over the x coordinate, or sine of the angle over cosine of the angle. And then after that, we introduced the other three trig functions, which were just reciprocals of the first three. So it was cosecant of the angle is just 1 over the sine. So you just take and do 1 over the y coordinate. So it's just the reciprocal of the y coordinate. Secant of an angle is 1 over cosine. So that's 1 over the x coordinate. So we're basically, for secant, we're just doing a reciprocal of the x coordinate. And our last one, cotangent, is 1 over tangent of the angle. So that's going to flip and put 1 over y over x, which flips to x over y. And so it's the reciprocal of the y over x ratio that we had for tangent. So keeping in mind those are those ratios, we can still pull, all we're pulling are x and y coordinates. It's just sometimes we're doing the reciprocal. But they're still coming from the unit circle. If they're not from the unit circle, calculator is where you'll use those. So cotangent of 3 pi over 4. You understand where 3 pi over 4 is. 3 pi over 4, again, on the coordinate, on the unit circle, is negative square root of 2 over 2 and positive square root of 2 over 2 for your coordinate. So for 3 pi over 4, the point is negative square root of 2 over 2 and square root of 2 over 2. And cotangent is basically the ratio of x over y. So if I do negative square root of 2 over 2 over positive square root of 2 over 2, I just get the value of negative 1. That's the cotangent of 3 pi over 4. All right. Pi over 6, just like 30 degrees. That point is square root of 3 over 2 and 1/2. And I need the secant of that function. So secant is the reciprocal of cosine. So for this one, I'm focusing on the x-coordinate, and I simply need to do the reciprocal of that x-coordinate. So I get 2 over the square root of 3. And you're welcome to leave it in that format. All right, tangent of 270. Again, identify where 270 lives. That's the one that's down at 3 pi over 2 in the middle of the third and the fourth quadrants. So that coordinate point is 0, negative 1. And I need the tangent, which puts the y over the x-coordinate. So for this one, notice if you put negative 1 over 0, it's actually undefined. And that's one of the angles for which the tangent function is not defined. The graph would have an asymptote, so you would put that that value is undefined, or I think not applicable when you answer questions. All right. 900 degrees, again, you have to figure out where that lives in the realm of degree world. So for 900 degrees, you would go around 360 degrees, around again another 360 degrees. I think that would put you at 720, and then you would go another 180 degrees, so that you have 360 once, 360 twice. Again, that puts you at 270, and then adding another 180, or pi, would put you back over here where pi lived. So 900 degrees coincides with 180 degrees. It's called a terminal angle. They end in the same place. So that coordinate point was negative 1, 0, and I need the tangent value there. So the tangent, if you recall, just puts y over x. So I put 0 over negative 1, which will give me a tangent value of just 0. All right. Negative 30 is going to wrap in a negative manner down to the fourth quadrant. So that coordinate point is square root of 3 over 2 and negative 1/2. Tangent puts y over x. So I will put negative 1/2 over the square root of 3 over 2. And dividing by a fraction, I can do the reciprocal of the denominator and multiply. 2 over square root of 3. My 2's cancel, and I'm left with negative 1 over the square root of 3. And you're welcome to leave it in that format. But that's the tangent of negative 30. Okay. Last question, cosecant of 3 pi over 4. So 3 pi over 4 lives in the second quadrant, where the point is negative square root of 2 over 2 and positive square root of 2 over 2, just from the unit circle coordinate point. Cosecant is the reciprocal of sine. So we're basically doing the reciprocal of the y-coordinate here. So we just take the square root of 2 over 2 and we flip it, and that gives us 2 over the square root of 2. So again, you're welcome to leave it like that, but if you feel compelled to rationalize it, it would be 2 square root of 2 over 2, and that would simplify to just the square root of 2. Again, rationalizing gets the square root out of the denominator, but both of those are the same thing. So again, whether it's sine, cosine, tangent, cosecant, secant, or cotangent, if they're values from the unit circle or something that can be related to one of those values from the unit circle, positive, negative, degree, radian, wrap a few times, it's just simply pulling x and y coordinates in this correct manner for whichever trig function is indicated.